Hello, my name is Joanna and I'm going to talk about what we did in this work called Machine Learning Model to Detect Fake Voice. You can cite the paper as you can see in the pink square. So let's talk about imitation. It was first proposed in 2012 in the paper Highly Transparent Steganography Model of Speech Signals using Efficient Wavelet Masking. And it was detailed in the paper on the ability of adaptation of speech signals and data hiding. So what is imitation? Imitation is a way of transforming a speech or secret audio so that it sounds like another speech or target audio with the primary purpose of protecting the privacy of a secret audio. How does it work? It works by reordering the samples or wavelet coefficients of a speech signal in a mapping process. So how does it work? We have any secret signal that is a speech signal, and it may seem similar to a host signal that is also a speech signal if its wavelet coefficients are sorted. When we talk about any secret signal, we talk about legible voice signals. When we talk about may, we say that the adaptation is feasible. When we talk about similar, we say that the square Pearson correlation coefficient between the host signal and the adapted secret signal is close to 1. And when the word sorted is used, we refer to a relocation process. Here I'm going to show you an example of imitation where we have a secret audio, we have a target audio, and an output audio. So the secret audio is the sensitive content, the content that we don't want others to listen. The target audio is used as the non-sensitive content, and we have a forged audio. So let's listen to the secret audio.
Olá, meu nome é Christian. Eu tenho 25 anos e eu sou da Colômbia. Minha profissão é engenheiro aeronáutico e oficial da
Now let's listen to the target audio. Let's play this song in the concert. People love it, and with this show, we can be in the newspaper's headlines tomorrow. Tonight is the night. Okay, then the imitation process is performed where the target audio was imitated by Christian's speech. So let's listen to the output. Let's play this song in the concert. People love it, and with this show, we can be in the newspaper's headlines tomorrow. Tonight is the night. The objective is to transmit the imitated audio instead of the secret audio. It can work between different speakers, even for different languages and genre. So in this case, the secret audio is hidden in the target audio, but this output file is not the same as the target audio. As we can see here, we have the signals in the time domain. The original speaker has a different signal, but the target and the fake audio have the same, similar signal in the time domain, but it's not the same. So we have the fake audio in this case with my voice, but it's not really my voice. What is the problem to be solved? A third party would not be able to distinguish between original content and imitated content. What happens if a fake audio is intended to be used as legal evidence, for example, in a court of law? So what can we do to solve this problem? We can use a machine learning solution to detect the fake audio that was created with an imitation process, with the imitation process that we explained before. The methodology was the following. So we divided this in 4 steps. First, we made the data labeling. The second step was the feature extraction. The third step was the post-processing data, and the fourth step was the machine learning algorithm. In the methodology, we had the data labeling, where we had the original speech recordings. So let's remember they were legible voice signals. We made a pre-processing where we normalized the signals to perform the imitation among them. After that, we could have the fake speech recordings to do the labeling of each one of the audios. After that, we can do the feature extraction to make the post-processing of the data and train the machine learning algorithm to validate it and see the results. In the data labeling step, we have a total of 43 people that participated, and we had a total of 1,086 voice recordings, and they are the original voice recordings. They were recorded in Spanish, in English, in Portuguese, French, and Tagalog. The people were women and men. We recorded them in a sample frequency of 44,100 hertz with 16 bits. Each audio file had a duration of 10 seconds in a WAV format and with different acquisition devices like computers or cell phones. So in total, we have 1,086 original audio files, a total of 10,000 fake voice recordings. So to perform the imitation process, we need that the audios have the same features in the sample frequency, in the duration, and everything like that to perform it correctly. After that, we made the feature extraction to build the data set. And the entropy of the signal was obtained using Shannon's equation that is shown here, where H is the entropy, pi is the probability of occurrence of the amplitude I in the audio signal. So this is what we did. We obtained the entropy of each voice recording, and after that we obtained the entropy of each second of the signal. So in total we had 11 features for each audio file to build the data set. That's how we made the feature extraction. It was a manual feature extraction with the entropy. We also plotted the data with two features, so we could visually check if it was possible to separate them in a machine learning algorithm in a way that we could see it. And we used logistic regression to train the model and a random split of 0.2. After that, we obtained the following results. So here we have a confusion matrix of the signal. So we have the real and the predicted. As we can see, all of the fake audios were classified correctly. 1,989 audio files, and none of them were classified as original. And 193 original voice recordings were classified as original, and only 36 were classified as fake. As we can see here, the metrics, we use precision, recall, and F1 score to determine to check the performance of the model. We can have good results, so it wasn't perfect with the original voice recordings, but all the fake recordings were classified correctly. So in the conclusions, discussion, and future work, the proposed machine learning model was used to classify original and forged audios that were made with an imitation process. The results showed an accuracy of 0.89, where all fake audios were classified as fake and a few original recordings were classified as fake. We can use it that if a legal authority accepted an audio as evidence, they could trust that this is an original audio. The use of entropy as feature helps the classifier to separate original and fake voice recordings. And we suggest using features that represent a similar behavior of the distribution of features that are learned by the model for future work. So that's it. This is a machine learning model to detect fake voice.